Admissions open.
A very warm welcome to one and all gathered here. It gives me immense pleasure in welcoming you all who have gathered under this online platform, one-day workshop on geospatial inclination towards water industry. The guest speaker for this workshop is Dr. Rajesh Kumar, JGM and Head EDRC LNT Chennai. Sir was the head of Geospatial Technology, Water and Effluent Treatment IC L&T Chennai from the year 2018 to 2021. Sir was a senior DGM and head of Engineering Design Research Center, Water and Effluent Treatment at L&T Chennai from 2021 to 2024. And now presently, Sir is the head of Engineering Design and Research Center, Water Effluent Treatment, L&T Chennai. Sir has completed his bachelor's degree in the year 1999 in RVS College of Engineering and Technology, Dindigul, and he has completed his master's in engineering at Anna University in the year 2001 with distinction, and Sir has completed his doctorate in Sastra University in the year 2009. Sir has also completed his doctoral science degree in the year 2024. Sir has about 24 plus years of rich experience in industry research, academics, administration, training, and development. Sir is a recipient of the Best Educationalist Award from International Institute of Education and Management for outstanding achievements in the field of education in the year 2013. And he is also the recipient of Rajiv Gandhi Education Excellence Award in the year 2013. And he is also won the Best Influencer Award in the year 2014. He is also the recipient of Research Excellence Award in the year 2022, and he has also awarded the Construction Industry Award for Excellence in GIS Automation for Irrigation Projects in the year 2023. Sir has also got various team awards, the Corporate Titan Award for Technical Excellence in the year 2023, L&T Process Improvement Award in the year 2023, L&T Project Management Conclave in the year 2023. Sir has got to his credit, yes, pre-sponsored research projects in one titled Preparation of Damage Assessment of Tsunami Affected Areas in Kadalur, Tamil Nadu. It's a DST funded project from a period of April to December 2005. And Sir has also worked in another project mapping of areas of inundation from Tarangambadi to Kolladam Mouth, Tamil Nadu from in the year 2005. And he has also worked in another project under the NRDMS scheme for assessment of stability, slope, and cut slope stability evaluation of air cut with SMR and suitable control measures. Sir has been in the field of academics as a Dean Professor, School of Engineering, Lovely Professional University, Punjab, from 2016 to 2018. Is notable, and he has also been the Assistant Professor in Civil Engineering in Sastra University, Tanjavur, from 2003 to 2010. And Sir has been the Director of Survey and Planning, Raven Constructions, Tanjavur, from 2010 to 2016. Sir has been an all-rounder in this field. His technical achievements include aerial lidar and drone survey implementation, GIS BIM integration, and his projects include execution of pipeline designs, land survey, total station, GPS, drone, lidar. Uh, your achievements are a never-ending process, sir. One day will not be enough to summarize your achievements. With no further delay, I would like to hand over the session to Dr. Rajesh Kumar, sir. Good afternoon, sir.
Good afternoon, all. Thank you for a very lengthy introduction. And to start with, I need to thank Mr. Saravana Kumar, Assistant Professor of SA Engineering College, without whom this presentation would not have been materialized. So coming to the topic, geospatial inclinations towards water industry. Uh, while uh, this geospatial technology was started or started evolving in the industry during 1980s and 90s. So what we'll be doing is we'll do or use this geospatial technology only for particular uh, applications like digitalization of a map, taking out information from uh, other maps of any area. So likewise, only we have did a lot things during 90s and 2000, even till 2000. 12 or 14 till 14 also we have done like that only, but after 2018, so when I joined wet IEC, so we have done a lot things here which had a very better significance also. uh, Most of the industries, they are not moving through towards geospatial technology. So why? Because the software purchase is costly, and they may not be there may not be any requirement from the client. But even though there is not any requirement from the client, so what we are doing is we are making it materialized when we are going for the applications. So 100 percentage we are going through engineering applications only here. So we are designing, we are innovating, we are uh, making tools, we are making the flows very easy. So for that only, we are moving towards this geospatial technologies. So in this presentation, so I'll be saying a very short introduction on geospatial technologies. What is it, and how we have taken into our water industry, our L&T for this. The second component is, so what are the flows we have designed, what are the innovations we have done, and the third one is how we have applied all these things towards the industry. So these three components I'll be presenting here. At the end, if you have any doubt, you can ask me, or else you can mail me, or else you can mail the coordinators also, so as they'll be sending the questions to me, so as I can answer. Most of you may be knowing that geospatial technologies involved three different processes. One is remote sensing, second is GPS, and third one is GIS. So when it comes to remote sensing, all of us knows what is remote sensing. So it's a very common process nowadays. So earlier, before 2000, when I was studying MTech in remote sensing, it was very difficult to know what is it. So, but now, so everybody knows what is remote sensing, what is satellite, or how it works. So what it happened because of internet. Internet, everybody is knowing it. So to start with, remote sensing is a process where we'll be collecting data without touching that particular data. You can collect any information on the earth without going to that particular place. So even a remote area where we can't reach, we can get images, or you can get information, or you can go for data, or you can collect any other details what is necessary without going to that particular thing. So I think most of us are civil engineers here. So you can start with surveying also. Surveying is will be going to that particular place to get the details. Whereas remote sensing, there is no need of going to that particular place. That is the difference between surveying and remote sensing. Then comes to GPS. Everybody knows it. Everybody has a cell phone. So you know what for GIS is used. Third one is GIS, Geographic Information System. It is a software. For what it is used, you may be having a knowledge on AutoCAD, where in AutoCAD we'll be drawing lines that you will be vectorizing in AutoCAD, but you will not be showcasing the spatial data on it, latitude and longitude. You may be having coordinates, but not the latitude and longitude. So those latitude and longitude, the so-called spatial data, will be linked with the non-spatial data through GIS. So GIS is earlier used for information system. Now it is not for information system. It is for lot many things, which we'll be seeing in the subsequent slides. So as I told, it is just a view of remote sensing, where we'll be getting the energy source. From the energy source, it will reach the target, and till it goes to the product applications. There is no need of touching that particular area. No need to know the complexity of remote sensing. Remote sensing, that's a simple process. So GPS is a simple process where we'll be getting latitude and longitude. GIS is a software. So all these three, remote sensing, GPS, and geographic information system, put together is called as geospatial technologies, which we are using it. We are going with GIS software, mostly with GIS software, but the data needed are being created or being captured or being acquired using GPS or using remote sensing techniques. So this already I told you. And the most important thing I want to say is lidar mapping. So we started with chain surveying. In the surveying, we started with chain surveying, then compass, plane table, then theodolites, then so on, so on, like this. Leveling, the digital level was there, electronic total station was there. So after that, we went to GPS survey, and now we are in aerial lidar. Okay, the accuracy of aerial lidar is very high. Within 2 months, we can complete the total process of surveying if we are going for lidar mapping. The possible higher the area, we need to go for lidar mapping. Okay. So the accuracy of it in centimeters, so as easily we will be getting all the other details, the derived details like contouring or DEM or DTM or whatsoever it may be. So land use, land cover maps will be deriving from lidar. So anything can be possible. So the accuracy leads to lot of things in lidar. So nowadays, what we are doing is, for any type of project, we are going for lidar. So we are not seeing the value of money, but we are seeing the advantages and quality of the data what we are getting using lidar. These are some of the digital solutions, so which we have created in our team by geospatial technologies. The first one is called as chuck planning. First one is called as chuck planning. So where we will be dividing the area into small parts when you are starting the irrigation system or any other bigger projects, mega projects. So where we are working out with 1,000 or 2,000, even up to 5,000 crores project. So there and all, the area is very high. It will be going till lakh hectares. So the CCA will be more. When the CCA is more, it is not possible for us to go with AutoCAD, and the manpower what we want to use will be more. We need 40 to 50 people in AutoCAD to do the check planning. Just division of land into pieces of required piece. Maybe a hectare or zero point 0.5 hectare or 2 hectare or 5 hectare. It depends upon the client specifications. So for that, we wasted lot of time in CAD. So when we joined, we thought of going towards geospatial solutions, and hence we have done it, where the 4 months to 5 months work can be completed within 15 to 20 days. When we are using AutoCAD, we'll be going with 4 months for a particular work. But now we can complete within 15 to 20 days using our geospatial technologies. Where we are going with conventional technology like AutoCAD, lot of human errors, manual errors will be there. So accuracy will be a problem by that time. Now everything is system generated, and hence there won't be any problem. But whenever I am saying that we are going for digital solutions, we will be keen in basic options also. We will be knowing what is the basic. Without knowing the basic, we will not touch any of the solutions. Because what will happen if we don't know what is the basic behind that particular process or behind that particular methodology? What will happen? So we may be giving 200 out of 100 marks. That may happen. So all basic things we'll be learning, and we are engineering the solutions. The second one is contour generation. Everybody knows. So just a small thing. You need to you need to submit the lateral longitude of that particular area for which we need to get the contour, and it will give the contour. And next one is automated pipeline routing. So automated pipeline routing is, so you can see just a line here where we'll be going with pipelines for a lakh hectare project I'm saying. So which will be done manually earlier, and now we have automated it based on some factors. The factors may be slope, land use, land cover, then bridges, then road crossings. Any crossings will be taking into the factor, and we'll be assigning some rank and weightage for this. Then we'll be going with the least cost part method uh, to find out the automated pipeline routing. So this also, when we did with a manual process, it took nearly 1 month or at least 25 days for a line, for one line, whereas we are doing within a day for one line. So that is the advancement we need to use like that. Simply taking Excel sheet and bringing solution for summing up and multiplication. So going that way will not be a proper digital solution. Instead, we need to engineer the digital solutions. We need to be the root cause for it. Whatsoever we know, like geospatial technologies, we are very well versed in geospatial technology, and hence we are going for it. So if you know any digital solutions, try to use it and engineer. Next, storage capacity, name itself, you may be knowing storage capacity estimation. For that also we have done it. GIS BM integration, the forthcoming slides we have details of it. I'll be showcasing it. Excavation quantity estimation. So I don't know whether slide is available or not. So I'll give a gist. If slide is there, I'll be telling more on it. So this GIS-BM integration, uh, after GIS-BM integration, we had excavation quantity estimation, where what happened is, so when we will be using manual process like trapezoidal process rule or Simpson's rule for excavation or quantity estimation, the uh, boundary will be intact, will be having a shape. But here, whenever we are going for excavation quantity estimation, in practical, we will not be having any intact boundary. Instead, it will be having a very irregular boundary. So through that, for that irregular boundary, we have done GIS process to excavate the quantity. Next, the most important thing what we are doing is flood risk analysis. So a lot of the area where we are doing projects are prone to flash floods. So anytime it may come. So we are doing flood risk analysis using GIS and HECRAS also. Then radar survey, as already I told. Then watershed and stream generations, the shape of the watershed and streams, whatever it is flowing inside the watershed. So these and all we have done digitally. And the most important thing is feature extraction. Earlier, we will be going for visual interpretation of the satellite imageries, but now we are doing it automatically. The feature classes will be extracted automatically. We will be training the sets, training the system, and then we'll be getting it. Then the most important thing, what we have started here is progress monitoring. When we want to showcase our digital solution, the first application what we have showcased is progress monitoring. So after designing, it will be going to the execution stage. When it is going to the execution stage, we need to know whether executions are happening or not. So as like college, there will be from top management to the lower management. So likewise here also will be having top management. So we'll be having CEO, then directors, then VPs, then GMs, then other project managers will be there. So project managers, if they want to showcase anything, so the ultimately the CEO or the higher management, whomsoever they need to go to the particular place to see the progress. Instead, what we have done is we have put everything into GIS environment. So from their place itself, they can see the progress. End of every day, he can see the progress. So site in the site, there will be update how much kilometer it has been done. Immediately, we can see it here itself. So likewise, we have created dashboards which has a greater impact in our industry. So this is a process of lift irrigation where I am working. We are doing with a lot of irrigation projects only, where we'll be having an intake or any river or any source of water. From that, it will be the water will be taken, and at last it will be distributed to the farmer land. Okay, so this is the main pipeline, and these are distribution pipelines. All these are distribution pipelines. These pipelines will be designing. So pump houses is there that will be designed by civil team, and these pipeline design will be done by the mechanical team. So this pipeline design, mechanical design, whatsoever they have done, we have automated using geospatial technologies now. This is the pipeline design process. So where it starts with survey, sorry, survey and data collection. Then we have this check planning process. Then we'll be doing pipeline routing. Then hydraulics and L section. And last we'll be preparing layouts, which will be submitted to the client. So that is the conventional way. So what we have done is, so now you can see here, instead of normal survey, total station survey, we have gone for LiDAR survey. So as we are capturing a larger area in very shorter time and accurately also. Planning, check planning, again we are using GIS based tool, which reduces more than 60% of the man hours, even time also. Next, automated pipeline routing. So there we have reduced nearly 90% of the man hours using geospatial technologies. Then this layout also we have reduced almost 90 to 95% of the drafting time. So this is one of the typical representation of, you can see a video here, whatsoever I have explained there. So we have done it for a project. Okay, here all are automated, and the outputs what we have got will be here. This check planning, how we are dividing the area into pieces, that is required pieces, using GIS tool, and here it's more than 80 percentage of manpower savings we are there. And this is micro distribution network routing. These are all routing. We have used least cost path method for the main pipelines. What we have done, these are the main pipelines, and then we'll be taking to the uh, water gems software. These are the visually appealing outputs. As per the client requirement, we'll be making the outputs and we'll be submitting it. Next comes GIS BIM integration. So you may be knowing on BIM technology already, building information modeling. So it will be producing three-dimensional model. So when it is always heavy, each and every model, what is being created with BIM is very heavy. So what we'll be doing is we will be bringing that BIM model into GIS. So when it is brought into GIS, all the BIM models maybe some 100 or 150 models will be there for each and every project. All those 3D models will be brought into GIS. So when it is brought into GIS, very easily we can see it. Not only those models will be bringing, three-dimensional pipelines also will be bringing here. You can see a video here. You can see this. This is a pump house model that has been brought to GIS environment. All or this booster pumping station, and these are the three-dimensional length pipes with chain edges also. You may be aware of chain edge. So each and every chain edge will be there, and you can see the land use. There is satellite imagery beneath this. It will be taken till end. It is other pump house, and these are the chain edges. The advantage of this is once we have done the design data, we will be bringing everything to GIS environment. What will happen is when we are brought to the GIS environment, it will be shown to the client before starting the execution itself. It will be shown to the client, to the higher authorities, so as they may decide not to place something here. It should have been placed there because of some encroachments. It's likewise. So we have brought all the pump houses, and it is ultimately the water is given to chuck planning. We have done chuck planning. You can see chucks here. You see these yellow colors are chucks. Each and every land is divided into chucks, and to each and every chuck we'll be going for the distribution pipeline network, so through which we'll be uh, providing water for the irrigation. This is storage estimation using GIS, where the visualization of that we are calculating the storage volume, and the visualization also we can showcase in geospatial technologies, which will be easy for the engineers, execution engineers, to decide how they need to go on. These are some other GIS workflow automations. What I told there, one is contour generation, other is water and stream generation, and the next thing is flood risk analysis. In flood risk analysis, what happens is we'll be using HECRAS or HECHMS software to find out the finished ground level, to finish ground level, so as the water may not be going up. So likewise, we need to go for the finished ground level. For finding that finished ground level, we need to do all these process. So you can see like IDF curve, it is intensity, duration, frequency curve. In case if rainfall value data is not available, we'll be creating this IDF curves. In some cases, in abroad projects and all, they'll be having this IDF values, curves with them. But in India, we don't have IDF curves for all the parts of the country. So in case if rainfall is not available, we ourselves will be creating this IDF curves. Then we'll be going for this runoff model, flood and race mapping, storm analysis, stormwater management, and this stage discharge curves also will be developing and will be submitting to the civil team, so as they will be proceeding with the design. And next one is excavation estimation. I told that we'll be going for some formulas like excavation formula. We would have Simpson's or end area process. Likewise, we'll be going for many formulas, but that formulas and all will not give the accurate value. Instead, we'll be creating the excavation profile in GIS with each and every contour what we got from LiDAR data. So the accuracy of this will be more. Excavation values what we have got from GIS we are using for vendor to give to the vendor for building purposes. And the most important thing what we are doing is digital geography. This is for a project, a lower circle. We have done it. So what we'll be doing is we'll be keeping all the layers one above the other, so as when it is given to the execution engineer, he will see it. He will see all the what to say, maybe this is pipeline routing, main pipelines, distribution pipelines, then land uses, check planning. So all these will be available in the single map. So they will be using for execution. This is progress monitoring. When it comes to uh, pipeline progress monitoring, we have four processes. The first process is called excavation. Second process is laying the pipeline. Third process is filling. And the fourth process is hydro testing. So all these four processes will be done for the whole design data that are being executed in the site. So what we'll be doing is we have created a GIS environment for dashboard, which is for progress monitoring. So what will happen is, so this will be given to the site engineer who is involved in execution. So he, after once on the end of the day, once the length is completed or the first process excavation is completed, he'll say that excavation has been completed. Just he'll fill it in the table what is attached with this. When he has filled it, so we can see all these things. This completed, not started. So all the details will be seen. There is no need for any one of us to go to the field to check whether the happenings are true or not, because our site engineer is doing it. So he will be updating in our environment what we have created, so as we can see it immediately, and you can take the stack of it, and any problem that happens here will be immediately solved by the management team. This is one of the very important thing which we have done here. This is one of the mobile application. In mobile, there is no need for the site engineer to take any laptop with them. Just in mobile, he can edit anything. So we'll be giving training to the site engineer also. He'll be doing everything on internet itself. Just he'll enter it. We'll be getting the output here immediately. At the end of the day, we can see how much length has been excavated, how much has been filled or laid or tested hydrodynamically. All these will be taken using this mobile application itself. Then we are trying it now as built update through mobile application. What will happen is when we are doing design and giving to the execution side, so the execution will not happen for the design data as such what we are given there. Due to some encroachment problem, people may not give their land for encroachment, or some other what to say, villages will be available where they don't want to pass the pipeline through their villages. Likewise, lots sort of problems will be coming. By the time we'll be executing a new path, the site engineer himself may decide some time. So when we are designing like that, so we'll update this as built. So whatsoever is executed at the actuals will be available in the application. Is this already I told? Building footprints and image segmentation processes also we are doing. Like from the satellite imagery, we'll be giving training sets, and based on this training sets, we'll be getting the output of like wall land cover, land use map, or whatsoever it may be. And one of the most important thing what we have developed is topo sheet dashboard. This topo sheet dashboard will be consisting of topo sheets of India. In some cases where it should not be produced, it will not be available. All other areas it will be available. So what we are doing is we have collected Survey of India topo sheets and we have created this topo sheet dashboard. But this will be working inside our campus, our for our mail IDs only. So if any topo sheet is needed for any working outs, they can download it very easily. This is done using GIS environment only again. So in case these are the process improvements what we have done in our GIS. So main is check planning. We are doing that with AutoCAD and Excel earlier, but now it is with ArcGIS fully. So the output is man-hour saving and accuracy. Pipeline routing, again they used AutoCAD and Google Earth, but now directly we have given automated GIS tools from 2023, where there is more than 90% of the man-hour saving. Similarly, survey, the start of the process is PPT itself, I told. So we used total session GPS earlier, but now it is with LiDAR and drone only. Accuracy is more, and it can cover larger area with a very smaller time. And flood risk analysis, we have not done it before, but now our team is doing this. So it is in-house implementation, and we'll do for a lot of iterations. And storage estimation or cut fill. So everything they used Civil 3D earlier. Now we have gone with ArcGIS. Similarly, for progress monitoring, it was not before, but we used ArcGIS online or ArcGIS software for doing it. So as it will be very much economical also. When it comes to layouts, we did using AutoCAD earlier. So 4 to 5 months they will be sitting, 5 to 6 engineers, craftsmen will be sitting and doing all this. But now we are using ArcGIS to do it. So when we are using ArcGIS, so the results are also appealing, very much appealing. So I may be concluding it, but before concluding, I'll be saying the three things. What are the achievements that we have made? The first thing what I need to say is this mechanical design workflow which we have made using GIS. This one. This is a conventional workflow which we automated, see everything using GIS. This is one of the greatest achievement. We are trying for patent also for this. If not patent, we'll be going for copyrights. So we are trying for it. Most probably within this year will be not this. Is 24 is going to over. So maybe within 25 we'll be getting a patent for this. This is the best achievement. And second one is this GIS BM integration. This is one of the excellent achievement which is used for decision making, full decision making. And whereas we can't bring all the models into BIM environment, we can bring all the models into GIS environment. That is what we made possible. And this and all anybody can do it. Um, this progress monitoring again. I think nobody has done it, but we are pioneers. We are L&T are the pioneers to do progress monitoring, or that VET-IC is pioneer for mechanical design flow process, and VET-IC is pioneer again for GIS BIM integration. So all are like one more feather on our head, and I think I can complete this already. It is 30 minutes, more than 30 minutes. And we are here now with this process improvements. So anybody, an engineer or practicing engineer or those who are working in company, so they can go for this GIS environment, which is very much beneficial for man-hour saving and getting efficient result and getting what to say error-free result also. So you can go for any larger area, and any number of data can be saved in this. Any number of data can be merged with the GIS. Any number of data can be displayed also. Any number of maps can be added in it, or you can do anything like Venn diagrams, A intersection B or A union B, or whatsoever it may be, you can do with this GIS. And thanks for your patient hearing. And if you have any questions, you can ask. Any questions? Hello? Any questions? Anybody available?
Hello.
Hello?
Sir, thank you, sir.
Thank you.
Thank you so much, sir.
Okay, thank you. Uh, I can leave now.
On behalf of the management, staff, and students in the Department of Civil Engineering, I would like to thank Dr. Rajesh Kumar sir for his valuable time and presenting his valuable insights on remote sensing and GIS. I think it would be an eye-opening session for all of us. Sir, there's been a question posed for flood risk analysis. How many years of rainfall data is required?
It depends upon the requirement. Maybe a 50-year or 100-year rainfall we need go for.
Thank you so much, sir,
For
for your
very
valuable
accurate
insight.
assessment, we need to go for 100 years of rainfall.
100 years of rainfall data is required, is it, sir?
Yeah, yeah.
Thank you, sir.
Thank you.
Thank you.
One more question, sir.
College. Admissions open at SA Engineering College.